Welcome to Study Guide Forum. Today we'll be looking at some likely questions for the Neco exam chemistry. So here there's some questions which I noticed that most students have. They're always having problem with this. So this is what some of the questions that we're going to be looking at, so that will help us, in solving some basic calculations that we are likely to face. In this question, the first one there says that calculate the number of hydrogen ion produced by 0.8 moles of tetraoxosulphate acid in water. Now we have Avogadro's constant to be 6.02 times 10 raised to the power 23. So remember, according to Avogadro's, this number stands for for 1 mole of any ion, any entity, could be ion, molecules, compound, atom, as the case may be. So being that we are given this, what it simply means is that we're going to find out the hydrogen ion present in this that can be produced. So before that thing can happen, since it dissolves in water, the first thing you will be looking at is to write a balanced ionic equation of what happened. That is to say, we'll have so what do we have here? From this, if the tetraoxosulphate acid will ionize in water, we are going to get 2 moles of hydrogen ion and 1 mole of tetraoxosulphate ion in um, in 1 mole of what? Tetraoxosulphate. That means 1 mole of tetraoxosulphate will give us 2 moles of hydrogen ion and 1 mole of tetraoxosulphate ion. So in this case, from what we have here, we are told to find the number of hydrogen ion that is present here. What it simply means is that 1 mole, to solve this problem, 1 mole of hydrogen tetraoxosulphate will give us 2 moles. Okay, I'm going to solve it in 2 different ways now. We know that since we know that 1 mole of any substance is equal to what? 1 Avogadro's number equals to Avogadro's number. That means 1 mole of this will give us 2 times 6 10 raised to the power 23. So that is what we have for this. If 1 mole of this will give us 2 mole of this, that means 2 moles of this will be equal to what? 2 times the Avogadro's constant, because we know that 1 mole of any entity gives us is equal to what? 1 Avogadro's number. So since this one is 2 now, what it means is that 2 times the Avogadro's constant. Now, what it means now, 0.8 mole of the same acid, the tetraoxosulphate, will then give us equal to 2 times 6.02 times 10 raised to the power 23 times 0.8. So what do we have here? We are going to have, if we multiply through, what we are going to have will be 9.63 times 10 raised to the power 23. That's the number of hydrogen ion that we produce by this. So the next question there we have is say calculate the amount of trioxonitrate ions in 3.52 dm cube of 0.05 mole per dm cube solution of aluminium ion. In the same way, we need to write down the chemical equation, balanced chemical equation of what really happened in the reaction. What we have here will be now, if it ionizes in water in solution, trioxonitrate, we have aluminium, then plus So this is what we have. From this equation, it means that 1 mole of aluminium ion will give us 3 moles of what? Trioxonitrate 5 ion. So, but here, it's a bit different in the sense that we have 0.05 mole per dm cube. That is, in 1 dm cube, it contains this. But what we are looking at, ion that we have in what? 3.52 dm cube. So, the first thing we're going to do now is to know the amount of ion that we are going to, the amount or the amount of aluminium, trioxonitrate 5 we have in this. That is what we are going to find out first. We were able to get that thing done because what we have here is 0.05 mole per dm cube, or that is for the hydrogen aluminium nitrate that we have here. The aluminium nitrate that we have here in this 1 dm cube is 0.05 moles. Now, the amount we have in this is what we are going to find out. And we know that to calculate the amount, what we do here is, okay, let's go this way. Oh, I did not even solve the second method of this. But that method, solving the second method means that you get the amount, the number of moles here. When you get the number of moles you have here, then at the end of the day, you then multiply it by Avogadro's constant, which will also result to the same thing we have here. Because in this case now, instead of finding the number of moles of hydrogen ion that we have in this, that will be contained in 0.8 moles, I did it directly in order to get the answer direct. I think this might be the fastest way of getting what you want, because we are moving now from what mole to what Avogadro's number. Is that okay? That is what we have done here. But then let's continue with what we are really doing in this other one. So here, so what we have here, as we have seen from what we have so far, then we need to find out the number of moles we have there. The number of moles we have here, or the amount that we have there, should be. Now we know that this is per dm cube. It means that 1 dm cube of water contains 0.05 mole of aluminium what? Trioxonitrate. Aluminium trioxonitrate. Since we have that, so what do we have in 3.52 dm cube? That will give us 0.05 times 3.52 dm cube. It will result to, when we multiply through 0.05 times 3.52. That will give us 0.176 mole. 56 mole. But that's not what we are looking at. Based on what we have here, 1 mole will give us this. So we can still go back to what we have in the same method that we use here, but a bit different in the sense that we're looking for only the amount of the ions. So what we have here, we know that 3.52 dm cube contains this of aluminium ion. So what it means here is that from a balanced chemical equation, it means that since we know that from a balanced chemical equation, since we know that 1 mole of this, 1 mole of aluminium trioxonitrate will give us 3 moles. 3 mole of what? Nitrate 5 ion. 3 mole of nitrate 5 ion. Now 0.176 mole of aluminium nitrate will then be 3 times 0.176. That will give us we have a 0.0 0.528 mole of what? Trioxonitrate, nitrate 5 ion. So this is what we have as our final answer. So the next one we're going to be doing here, we'll be looking at this next question. And now, if you are joining us for the first time, we want to encourage you to subscribe. And then, if you have any question, you can also leave it in the comment section. And then you can share and like. And meanwhile, the question we are solving here will be in the description of this very video, so that you will be able to look through it. Perhaps some of you might not be able to see my funny handwriting very well, but then in the description section there, you're going to read exactly what I have here. Okay, let's go ahead. Let's continue. So let's go to the next one, which is calculate the mass of sodium hydroxide required to prepare 5.0 dm cube of a 0.105 mole per dm cube of solution. Now this is where we are trying to prepare a solution that will have a 5 dm cube. No, from here, from here now, what we're looking at, the mass we require, the mass that we require to do this is what we're looking for. Now, note very well, we have this in 1 dm cube. This is what we have, 0.5105 mole in 1 dm cube. But we want to know what we will get in this, the mass that we require. So to do this now, we need to find out, we are giving the mass, relative molecular mass of sodium hydroxide. So here, what are we going to do? The first thing we do is to know the moles or amounts, the moles that will be in this from in 5 dm cube. So from what we have here, it means that 1 dm cube of water has what 0.105 mole of sodium hydroxide. Now 5 dm cube of water will then give us 0. times 5 all over 1. So what do we have here? What we have here will be 0.15 times 5. What we have will be 0.525 moles. This is what we need in 5 dm cube. In 5 dm cube. And now to get the mass, what we do in the mass, and we know the other way around, okay, this will be mole per dm cube too, mole per dm cube. So we know that concentration in mole is equal to amount over what? Volume. Okay, that is not really what we want. That will give us this. But then what we're going to do here is to calculate. What we're doing here is to use, we know that mole is also mass concentration over what? Relative molecular mass. That means the mass. Now, if you cross multiply this, now what we have is mass is equal to mole times relative molecular mass. That is to say, our mole is what? 0.525 times relative molecular mass of sodium. That will give us, we'll multiply by 40. We have that is the mass that we require will be 25 grams. 25 grams is what we need of gram per mole per dm cube. That is what we need, that will give us the required concentration that we're looking for in 5 dm cube. So the last one we have there, let's look at the last one. the last one we have, they say that if 5.61 gram of barium chloride were dissolved in 200 cm cube of water, calculate the concentration of the resulting solution in mole per dm cube. Now, the barium chloride dissolved in what? 200 cm cube. And we are looking for what will be in 1 dm cube. That's mole per dm cube. Now, what we mean is that we are going to get what we have here. One of the ways of solving this thing is you can start, this is a question of moving from what gram to, okay, we're looking at it in moles. We need to know what you have in moles. That is from mass. Now we're moving to the moles. So what we are going to do here is, well, there are two ways we can do this, but I think I'm going to solve it based on the simplest and the fastest way of doing this. So in this case, we have, it means that 200 cm cube of water has what? Contain what? 5.6 grams. So what do we have in 1000 cm cube? Because 1000 is equal to what? 1 dm cube of water will give us what? 5.61 over 200 times 1000 over 1. So what we do here is we can cancel out. This will give us 5. 5 multiply that. 5 multiply 5.6. 5.61 times 5 will give us 28. 28.05 what? Grams. So this is the grams required. So, but the answer we need is mole per dm cube. That is gram per mole. We have it in gram per dm cube. Sorry, gram per dm cube. This is gram per dm cube now. So we need it in what? Mole per dm cube. To get it in mole per dm cube, what we're going to do now is mole per dm cube will then give us, because we know that mass over what? Relative molecular mass, and we are given the relative molecular mass of barium chloride, which is 208. 208, that will be 28.05 multiplied by 0.208. That will give us equal to, divided by 208, divided by 208. We have, what we have there will be, what we have is, in mole per dm cube, you have 0.5 mole per dm cube. Thank you so much. If you have come this far, we thank you so much for being part of the class, and we want to encourage you to subscribe if you have not, and make sure you share and like. Leave your comment there. We will always attend to you, and I wish you best in your exams. I wish you the best. Thank you so much.